Hey guys, Mr. Miller here. It is Thursday, and I thought I'd provide you a little bit more help with problem solving. So I'm actually going to go through the 5 problems that I gave you. If you want to use this, you are certainly welcome to. Reminder: you have this to do that's multi-shot. Then you're going to have 5 questions that are single shot, which will parallel the initial ones. So in this particular case, we got Damon who's deciding to paint his room, but he cannot decide upon a color. He's deciding between green, red, and blue. You see a spinner over here, and that spinner basically indicates that he's going to simulate his choice 180 times, right? How do these results compare with what the uniform probability model of this situation predicts? So, in terms of taking a look at what we have over here, you can see that this chart is basically broken up into 3 equal sections. So if you simply took 180 and you divided it by 3, it would tell you how many times it's supposed to happen. This would basically fall in the area of a theoretical probability. So that means that the number of green out of 180 spins should happen 60 times. The number in red should also happen 60 times, and the number in blue should also happen 60 times. If I check that answer, I should be good to go. So in theory, that's what's supposed to happen. Then it goes on to say, hey, if you click this icon up here, you're going to find out exactly, based upon a simulation that they ran, what actually did happen. So the number of times green was chosen was what? 82 in the simulation. It was only supposed to happen 60 times. So the number of times it was chosen was greater than the 60 that was expected. Number of times red was chosen was only 42, which is far different than the 60 it was supposed to. That would be less than. And the number of times blue was chosen was about 56, and obviously 56 is also less than what was expected. The results of the simulation, now you're going to get, this is kind of a gray area, you're going to get 2 choices, fairly close or not very close. And I think in this case, it's pretty safe to say we're not very close in terms of our scenario. All right? So there's problem number 1 and how you should attack problem number 1. Moving on to problem number 2. On problem number 2, I erase what I've got here. And in this particular problem, we have a freezer manufacturer testing the thermometer on 80 new freezers. And all 400 tests were run, or thermometers were run in a 5-day period. You want to buy the freezer from this manufacturer only if the probability is less than 5%. So the way I took a look at this, 80 new freezers. Each day, a freezer manufacturer tests the thermometer on 80 new freezers. So if I took a look at this, we have a total of 400. We have 6 plus 4 plus 6 plus 5 plus 5. So you can see we're at what? 10, 20, 26 of them out of the 400 tests are defective. 26 out of the 400 tested are defective. If I take 26 and I divide it by 400, then I get 0.065, and 0.065 as a percent, if I move it over 2 places to the right, is 6.5%, which means 6.5% of these, in essence, are junk. So, do you think the person is going to purchase these? The answer would be no. Why? Because we have 6.5% of them are defective. So 6.5, check, we're good. Okay? Questions on that one. So again, all we did was we added up the 5 numbers that they gave us. That gave us our numerator. I paid attention to this 400 up here. And so I took that 26 divided by 400 because that's how many thermometers were tested. And that came out to 6.5%. Moving on to problem number 3. On problem number 3, you see a spinner again. You have a set of flashcards that you test, one of 4 mathematical operations. You draw each card at random, perform the operation, put it back. You then are going to use the spinner with colors to simulate this drawing 220 times. So 220 times, if I take 220 and I divide it by 4, because we have 4 equal sections, oops, 220 divided by 4 equal sections, I believe we should be at 55. Yep, 55 is what my calculator says. So that means it should happen 55 times in my 220 attempts. So 55, 55, 55, and 55. Again, each of those are equal in terms of the picture. We're going to check our answer. Should be good to go there. We move on where we compare now, just like we did in problem number one, we're going to compare with a simulation. So in our simulation, as you can see here, we have green, we spun it 81 times, red 33 times, blue 73 times, and gray, which represents division, 33 times. So we are running a big gamut there. I got to believe this is not going to be very accurate in terms of the comparison. So the number of times an addition card was chosen was 81. And how does that compare with the 55? It's much greater than the 55. The number of times subtraction card was chosen was 33, as you can see by my chart. And we were expected to do it 55, so it would happen less than expected. How about multiplication? Multiplication was chosen 73 times, which is greater than expected. And then the last one, division, was only chosen 33 times as well, which is less than expected. So the results of the simulation, in my opinion, are not very close to the predicted by the uniform model. Okay? Moving on to question number 4. Question number 4. We have Ray practicing shooting free throws. He attempts 20 shots each week, keeps track of the number of successful shots. His coach wants him to make at least 80% of his shots. He incorrectly said he made 20.5 of the shots over the 10-week period. Decide if he has met the coach's goal and find his likely mistake. So what I would probably do here is I would take all those numbers for the weeks. He shot 20 each week. So you know that over a 10-week period, he would have shot 200 of those by taking 20 times 10. And then the other thing I would do to get our numerator is I would go ahead and add up 16 plus 15. In other words, you're adding up all the weeks. 16 plus 15 plus 16 plus 17 plus 15 again plus 15 again plus 17 plus 3 16s. I totaled out 159 there. And I'm going to take my 159 then, 159, and I'm going to divide it by 200. So the 159, remember, is the total that he made. And 200 would represent the total shot. Okay, total we made over total shot. If I take 159 in and I divide it by 200, my decimal turns out to be 79.5, or actually 0.795. Oops. 0.795 is my decimal, which translates into 79.5%. 79.5%. He was expected to make 80%. You guys would argue here that we want to round it up. I would say, no, you didn't make your 80%. So I would say no, because he only made 79.5%. Unless you see something that says to round it up, nearest percentage, I don't see anything there. I'm going to check the answer, and I'm good to go. Part 2 there. What was Ray's likely mistake? He forgot to include week 10. That doesn't sound realistic. He found the average number of successful free throw shots per week. I don't think that's it. Found the probability of an unsuccessful. So if you took that, 20.5 and added it to 79.5, he actually found the probability of unsuccessful shots. Yep. And moving on to our last problem here, problem number 5. Problem number 5, let's talk about food, one of our favorite topics. We have a barbecue going on. We have a spinner, and you can see on the spinner we have 2 sections of steak, which are going to account for 50% of the spinner. You have 25% chicken and 25% burgers. So if we're talking about in our uniform prediction, based upon theoretical probability, that spinner, you should say, hey, looks like to me half the time's going to be steak because it's 25% plus 25%, so 50% of 160. It looks like a quarter of it, or 25%, is going to be burgers. So if I took 160 and I multiplied it by 0.25, I'm going to get 40. And then I'm also predicting the same exact situation for chicken. Good there. And then again, we have to pop this up. This is the third time we've done, in essence, the same thing. So when it comes test time, if I pop this on here 3 times on problem solving, I think you can expect this to appear. So steak, 99. How does that compare? It is greater than. Remember, this chart represents, your simulation is representing experimental probability. Number of burgers, they said were 24, which is much less than. Chicken was, what, 37? It is also less than. And I think because there's such a drastic difference between 99 and 80 and 24 and 40, I think, to me, I'd say it's not very close. Good to go. That'll do it for 16.6 today. Hope you have a great day, and good luck. Remember, you have 2 pieces of this puzzle, and the 2 pieces are, you have the multi-shot first, and then I'd follow that up with the single shot, and that's due by tomorrow, 3:30. Thank you very much. Have a good one.